Hi students, in the previous two sessions, we have been discussing about terminology of electromagnetism. They are magnetic field lines, magnetic flux density. In the previous section, we have discussing about magnetic flux density. Magnetic flux is number of field lines passing through the area is called magnetic flux. It is denoted letter pi, units is Weber. Magnetic flux gives us the value of strength of the magnetic field at every point in the field. That's why strength of the magnetic field is equal to magnetic flux by area. Magnetic flux depends on the orientation of the plane of area. Means if the plane of area changes, magnetic flux changes. Already you see, when the plane area makes an angle theta with the field, means like that, the flux changes. Flux is BA cos theta. When the field is perpendicular to the field, when the plane area is perpendicular to the field, the magnetic flux is maximum. When the magnetic flux is maximum, strength is maximum. This strength is technically called magnetic flux density. Magnetic flux density means the number of magnetic flux passing through the plane area perpendicular to the field. That is the magnetic flux density. That's why magnetic flux density is equal to magnetic flux by area. Units of magnetic flux density is Weber by meter square, is also called as Tesla. Now what happened? The plane area which is parallel to the field lines. Whenever the field lines pass through the plane area is parallel to the plane area, the flux is 0. Means there is no field lines passing through the plane area. Now, in this section, we will discussing about magnetic field due to currents. What is the meaning of magnetic field due to currents? If you take three different shapes of wires, one is straight wire, means like that, straight wire. Second one is circular coil, means you made like this, circular coil. Third one is solenoid, means the arrangement like this. This is the solenoid. Now, when the current is passing through the straight wire, according to acid experiment, you know that the wire produces the magnetic field. Whenever the current passes through the wire, the magnetic field produces around the wire. Whenever the current passing through the circular coil, according to acid experiment, the current carrying wire produces magnetic field. That's why the coil produces the magnetic field. Whenever the current passing through the solenoid means long coil. The long coil is called solenoid. Whenever the current passing through the solenoid, according to acid experiment, the current carrying wire produces magnetic field. That's why the solenoid produces the magnetic field. In English, there is one proverb is there, where there is a will, there is a way. Like that, where there is a current, there is a magnetic field. So, current carrying wires produce magnetic field. The current carrying wire produce magnetic field discussed in three ways. One is magnetic field due to straight wire carrying current. Second one, magnetic field due to circular coil. Third one, magnetic field due to solenoid. We know that magnetic field is characterized by strength and direction. Now, when the current passes through the straight wire, magnetic field produced around the wire. Now, what is the direction of magnetic field? When the current passes through the circular coil, then the magnetic field produced around the circular coil. Now, what is the direction of magnetic field? When the current passes through the solenoid, it produces magnetic field. Now, what is the direction of magnetic field in the solenoid? This is the meaning of magnetic field due to currents. Now, let us discuss one by one. Magnetic field due to straight wire carrying current, magnetic field due to circular coil, magnetic field due to solenoid. We can understand the magnetic field due to straight wire with the help of the activity. Look at the slide. Take a wooden plank and make a hole and place the wooden plank on the table. Now place the retard stand on the wooden plank. Now pass the copper wire which is passed through the hole and rubber knob of the retard stand. Now connect these hands, copper wire hands, connect to the battery through the switch. Now place the 6 or 10 magnetic compass around the hole. Now switch is on. When the current is passed through the wire, means here wire in such a way the wire arranged in vertically position. When switch is on, the current passes through the wire. Then the magnetic compass needle deflected, means directed tangent to the circle. They are in this way. Actually, the magnetic compass needle shows north-south direction. Whenever the current passes through the wire, the magnetic compass needle directed tangent to the circle. The shape of the magnetic field lines must be circular lines. Now, these circular lines around the world concentrated circles. Now, this concept understood. Now, what is the direction of magnetic field in this case? Now, look at the board. We know that when the current passes through the wire, then the magnetic field produced around the conductor. Now, what is the direction of magnetic field due to the straight wire? This is the straight wire. Now, the direction of magnetic field due to the straight wire is determined by right hand thumb rule, which is determine magnetic field around the wire. It states that thumb is in the direction of current, then the curled finger show the direction of the magnetic field. This is the right hand, thumb in the direction of current. This curled finger shows direction of the magnetic field. Once apply this case, here current is flowing in vertically upwards. This is a vertical upward. Now, what is the direction of magnetic field produced by the wire? Now, direction of magnetic field due to the current wire is given by right hand thumb rule. Now, thumb in the direction of current, this is a thumb, you know that this thumb, okay, this thumb. Thumb in the direction of current, this curled finger shows direction of the magnetic field, direction of the magnetic field. Now, the current in the pass in the vertical direction, the field lines in anti-clockwise direction. You know that this is anti-clockwise, this is the clockwise. Now, current passes through the vertically, the magnetic field lines, the direction is anti-clockwise direction. That's why the direction of magnetic field, the current passes through the straight wire in vertically, the direction of field lines, anti-clockwise direction, anti-clockwise. Now, when the current is passes through the wire in vertically downward, what is the direction of magnetic field? Direction of magnetic field due to the straight wire given by right hand thumb rule. Right hand thumb rule. Thumb in the direction of current, curled finger shows direction of the magnetic field. Now, this is the current. This is the current direction. Thumb is in the direction of current. Now, this curled finger shows direction of the magnetic field in the wire. Now, current in the downward direction moves in downward direction. The curled finger shows direction of magnetic field. Now, the field lines in the wire is and means clockwise direction. This is the clockwise. Okay, this is the anti-clockwise, clockwise. When the current is passed in vertically downward, the field lines, the direction of field lines, clockwise direction, means like that. This is the direction of field lines. Now, one more. This symbol, the point symbol represent the current out of the page or out of the board, means like that. The current direction is out the board or out the page. Now, what is the direction of magnetic field in this case? Okay, right hand thumb rule gives the direction of magnetic field. Now, you know that. Now thumb in the direction of current, out the page. Now, curled finger shows direction of the magnetic field, direction of the magnetic field, outward. That's why the direction of magnetic field is anti-clockwise direction, anti-clockwise. When the current is passes out of the board or out of the page, your board, that's why out of the board. The direction of field lines, anti-clockwise direction. Now, what happened? The current passes into the board or into the page. If you take page, into the page. If you take board, into the board, into the board. Now, what is the direction of magnetic field in this situation? Now, current is into, here into mass indicates the current into the board. Now, you know that by using right hand thumb rule, you can say the direction of magnetic field lines. Now, thumb in the direction of current, curled finger show the direction of magnetic field. Direction of magnetic field. Now, into the board. Now, curled finger shows direction of magnetic field. Means clockwise direction. Clockwise. This is into. This is a direction of magnetic field. Direction when the current passes into the board. Into the board. Now, from this, what you understood that when the current passes in the wire in a vertically direction, the magnetic field lines direction is anti-clockwise direction. Anti-clockwise. When the current is flowing in vertically downward, the direction of field lines is clockwise direction, clockwise. When the current is passes into the board, the direction of field lines is clockwise direction. When the current passes out the page, the direction of field lines is anti-clockwise. Anti-clockwise. Now, let us start magnetic field due to circular coil. You can understand magnetic field due to circular coil with the help of activity. Take a drawing board, this is the drawing board, and fix white paper sheet over on it. Make two holes at position A and B. Now passes the copper wire, this is the copper wire in the shape of coil, copper wire through this hole in drawing board. Ends of this wire connected to the dry cell through switch, there is a cell or a switch. When the switch is on, the current passes through the coil in this way. Whenever the current passes through the coil, there is a magnetic field produced around the coil. Now, what is the direction of magnetic field due to circular coil? The direction of magnetic field due to circular coil is determined by right hand rule. Right hand rule. Right hand thumb rule, right hand rule, both are different. Right hand thumb rule we use when the current passes through the straight wire, and also use at any point of the wire you can find the direction of the magnetic field by using right hand thumb rule. But right hand thumb rule which is used for circular coil and solenoid. By using right hand rule you can determine the direction of magnetic fields. Now apply this one. Right hand rule states that when you curl our right fingers in the direction of current, thumb gives the direction of magnetic field, means the direction of magnetic north pole. What is the meaning that? Now our right hand curled fingers. Now when you curl our right hand fingers in the direction of current, this is the direction of current, means it is a clockwise direction. Now this thumb gives the direction of magnetic field, means the direction of magnetic north pole. Thumb gives magnetic north pole. Whenever the current passes through the wire, there is a magnetic produced. Now what is the direction? By using right hand rule you can apply, you can say direction of magnetic field for the circular coil. Now this is the curled finger in the direction of current, Thumb gives direction of magnetic field and direction of magnetic north pole, means this is the current, thumb gives, this is the north. Now this north, now this is facing, you know that it is a facing. Now facing the coil, south pole, act as a south pole, means when the current is flowing clockwise direction, the face of loop acts as a south pole. This is the face, this facing side, face of loop act as a south pole. Okay. Now, in this case, for example, here current passes in anti-clockwise. You know that current passes from positive terminal to negative terminal. This is the direction of current. Now, what is the magnetic field direction? By using right hand rule, you can direction of the magnetic field for this situation. Now, current curled fingers in the direction of current. Thumb gives direction of magnetic field. It means direction of magnetic north pole. Thumb gives north pole. For example, this is the direction of current anti-clockwise. Thumb is north, means the face of the loop acts as a north pole. This is the south pole. What you observe? When the current passes in the coil in clockwise direction, the face of loop acts as a south pole. When the current passes through the coil in anti-clockwise direction, the face of the loop acts as a north pole. Now, next, what are the direction of magnetic fields at point A and B? At position A and B, what is the direction of magnetic fields? At a point, you can use right hand thumb rule. You are not using throughout the coil. If you use throughout the coil, you can use right hand rule, but any point on the wire, you can use right hand thumb rule. Now, this is the point. Now, direction is in this direction, straight. Now, at the position, the direction of field lines in anti-clockwise. Anti-clockwise. At the position, the current is in downward direction. When the current is moving in downward direction, the direction of field lines clockwise direction. This is the clockwise. Clockwise direction. Similarly, like that, you can say direction of magnetic field at positions A and B in this situation. Now, what you understood this one means the direction of magnetic field lines perpendicular to the plane of coil. Plane of coil. For example, this is coil, the field lines perpendicular to the coil, plane of the coil. This all condition you can apply in a similar way. You can say in a similar way, easy. Now, this is the direction of current. The current passed through the coil is a clockwise direction. Clockwise. Now, the face of loop acts as a south. South means direction like this, here like this. Now, this is the south pole. The current passes through the coil in a clockwise direction, the face of loop acts as a south pole. Similarly, when the current passes through the coil in anti-clockwise direction, anti-clockwise means like this, means the face of loop acts as a north pole. North pole. This is the direction of magnetic field when the current passes through the coil. From this concept, what you understood that when the current passes through the coil in clockwise direction, the face of loop acts as a south pole. When the current passes through the coil in anti-clockwise direction, the face of loop acts as a north pole. Let us see magnetic field due to solenoid. Okay, student? We can understood the magnetic field due to solenoid with help of the activity. Look at the slide. Take a wooden plank, fix white paper sheet over on it. Make equidistant holes on the plank. Now passes the copper wire through the holes. It forms coil. This long coil is called solenoid. A solenoid is long wire wind in a closed path helix. Now join the ends of this coil solenoid, connect to the battery with switch. When the switch is on, the current passes through the solenoid. Whenever the current passes through the solenoid, the magnetic field produced around the solenoid. Now, the field due to the solenoid in the next figure. This is the pattern of field lines due to the solenoid when the current passes through the solenoid. Now, what is the direction of field line or field due to the solenoid? Look at the board. Solenoid means a long wire wound in a closed path helix. Helix means a cone shape in the form of spiral. You know that spiral binding, spiral. Like that, the solenoid is there. Now, whenever the current passes through the solenoid, the magnetic field produced in this pattern. Now, what is the direction of magnetic field due to solenoid? The direction of magnetic field due to solenoid is determined by right hand rule. Right hand rule means the curled fingers in the direction of current, thumb gives direction of magnetic field, direction of magnetic north pole. Now, here current passes in clockwise like this. In the direction of current, thumb gives direction of magnetic field or the direction of magnetic north. This is the north. Automatically this is the south. Means here solenoid, one of the hand behave as a north pole, other hand behave as a south pole. Now field lines from like this. If there is a north, it is a field lines away from the solenoid. If it is south, the field lines coming towards the solenoid. Now, outside the solenoid, the direction of field lines from north to south. Means north to south. Inside the solenoid, the direction of field lines from south to north. This is the direction of field lines inside the solenoid from south to north. This situation compared to the bar magnet. This is the bar magnet. This is the north pole, south pole. Outside the bar magnet, the field lines from north pole to south pole. This is direction of field lines for the bar magnet outside. This is inside, south. Now inside the bar magnet, the field lines are from south to north. Once observe here. For solenoid, outside the solenoid, the field lines from north to south. Inside, south to north. Similarly, the outside the bar magnetic lines from north to south, inside south to north. what you understood that when the current passes through the solenoid, the solenoid behave as a bar magnet. This is the bar magnet. By using right hand rule. From this three situation, what we observed that current carrying wires produce magnetic field. Now, in the next section, we will discuss about when the current carrying wire is kept in magnetic field, what happened? What happened when the current carrying wire is kept in magnetic field?